Okay, so I have returned from the trailer and I'm sitting at the computer uh, here in the Double G Studios editing booth and getting ready to edit all the astrophotography pictures that I took night before. Really, I got all the editing done on all of them except one. I got one more to go, so I thought I would turn the camera on and try to demonstrate how the process of producing an astrophotography image takes place once you have your stack of initial photographs. As you recall from a bit ago when I was talking about what I was doing out at the trailer with the telescope, I showed how I was taking one picture every 15 seconds to build up a stack of photographs of deep space objects. Um, so the idea is that once you have your stack of photographs, you would then use specialized software to try to extract as much information as you can out of them. And one of the purposes of using a stack of photographs, and think of it as a stack, just like that, where the first one you took is at the bottom and the last one you took is at the top. What software will do is scan through all those stacks, and I'm probably not explaining this very well, but the way I understand it is it's pretty much going to improve the signal to noise ratio from image to image, and the more images you get in a stack, the better the signal to noise ratio will get, the more detail will be able to be drawn out. And if you get a large enough stack, you can bring out a lot of details in deep space objects, even with um, a cheap, I'll call it a cheap telescope, what I'm using, as opposed to more high quality devices. Anyway, so what's got to happen is you have to take all the pictures that you took on the telescope, you need to download them to your computer, and then you're going to use software to process them. So I'm at that point where I'm getting ready to do that. I have downloaded all of my astro photographs I took last night to the computer, and I got one more object to process, so I'm going to show you how that's done. Let me turn on my desktop and shrink me down into the corner. Alright, there we go. Okay. So the software that I'm going to be using is this piece of software here called Siril, S-I-R-I-L. It's free software available on the internet. Search Google, you'll find it if you're interested. And this software is used by a lot of astrophotographers around the world. It's again, it's free use software. They do ask for donations. But that's the software I'm going to be using to process these images. The images I'm going to be processing are in this directory here. The object I shot a picture of last night is called C20, and I ended up with, let's see, I think it's about 67. Yeah, I ended up with a stack of 67 pictures of that object before the battery on my telescope died. Normally I'd like to get 100 or maybe 200 pictures of objects when I shoot them in deep space, but we'll work with the 67 that I got. Notice that the file extension on the name of each of these pictures is FITS, F-I-T-S. Astrophotographers work with raw format photography. A lot of digital cameras will generate raw images when you take a picture. And FITS is a form of raw image format that's preferred by a lot of astrophotographers. So the telescope that I have, the Dwarflab 2, saves its images in FITS format. So I have 67 of these. I need to copy all these files over to a specific directory. The directory I need to copy it to is a directory labeled lights, L-I-G-H-T-S. So create a lights directory somewhere on your hard drive. Really doesn't matter where, because you're going to tell S-I-R-I-L, you're going to tell Siril where this directory is located. But anyway, you'll need an empty directory called lights, and that is where you will deposit all your FITS files. So let me copy those over. Boom. Now I'll go back to that directory, and I am done with that. You will notice there are some other folders here in this particular directory I'm in, a directory I created called Cyril Temp. Flats, darks, biases. Using fancier telescopes than the one I have, you will take additional pictures in addition to your actual photographs of the sky object. You will also take pictures that are used to help calibrate the photographs and help calibrate the photographs better, I guess, for lack of a better way to say this. Again, I'm a real novice at this, so I really don't know a lot about it. I do know that flats, darks, and biases are very specific photos that you take to help calibrate your telescope and get the most out of it that you can. I'm not going to be using any of those in the way I'm particularly doing it. I'm just going to be using the actual photographs that I took, the FITS files. So I don't have any flats, I don't have any darks, I don't have any biases. And that's just fine. At this point, I am ready to activate the software and work on processing my last image. Alright, so let's activate Cyril and get the show on the road. Okay, there we go. So Cyril is a piece of software that uses scripts to get its job done, and you see the highlighted blue button called scripts. But before you run a script, the first thing you got to tell Cyril is you do have to tell it what to use for its working directory. I've already done that, and in fact Cyril will list the working directory right up here under the latest version listing. So my working directory is C:\Cyril temp, which has the folder lights in it, as I explained earlier. So once you have told Cyril where your working directory is, and your working directory is ready to go, you can go ahead and run the script that you need. And in my case, the script that I need is the last one on the list. It's called pre-processing without DBF. Basically, that means without darks, biases, or flats. So I will run the script, and in this window over here we can watch the script execute all its commands and what all they do. So what is happening here? I don't have a clue, other than I do know that the software is looking at every image in the stack, and it's going to match each image to each other by looking for common stars that are in each image that it can match them together. So it'll make sure each image is aligned perfectly by doing star matching. Other things that it does, I think it does some sort of analysis on all the stars in the pictures, and it reports on all the data on all that, and that's used for something else, not really clear what. But anyway, that's some of what is happening with all the processing that is going on here with the stack of images that I've supplied it with. The other thing it'll do too is it'll actually reject pictures also. This is where it didn't used to be a problem in the past, but it is now, thanks to Elon Musk and all of his satellites now orbiting the Earth. It's very common for a satellite to streak through and ruin one of your pictures. So Cyril will also be looking for those frames, or for those pictures, and pictures that have a satellite track coming through and ruining it will be rejected. They will not be included in the final stack. There's a message here at the bottom that says rejection stacking in progress. When you see that message, Cyril is on its last step of the stack processing, and it will complete. When Cyril completes, the screen is blank because the process has been completed. But the reason the screen is blank is it's ready for you to load the result image into it for further processing. So the resulting image, after processing your stack of images, is found in the working directory. Looking at the working directory, we can see that Cyril has created a new folder called Process and has deposited a file called result.fit. This is the result of the processing of the stack of images. This image here can now be loaded into Cyril for further processing, which I have just done there. So here we see a picture of the image that I took of C20, and we're not seeing anything, which is normal on the first look. We are looking at this in the linear format. Again, confessing to be a novice at this. I'm not sure what that means, other than, to me, it's sort of like if I was looking at the object in the sky, maybe with a pair of binoculars, this might be what I would see. But anyway, the other thing I must confess, I'm certainly by no means any expert on this software. Everything I'm doing with it, I've just done by trial and error. I did watch a video on YouTube, which was frankly not that helpful. It was pretty much, a lot of it was over my head. I took a couple of things out of it that I have used. Other than that, everything else I'm doing here is literally just trial and error. So please do not consider this to be any sort of a tutorial. This is not a tutorial. This is me stumbling through this software, trying to improve on the image that has been generated. So, having said that disclaimer, right now we are looking at the first look at the resulting image in the linear format. While it's in this linear format, I'm going to do two things. I'm going to go to the image processing section, go to star processing, and I'm going to desaturate stars. It's recommended you do this while you're looking at the image in linear format. So I'm going to do that right now. You might not notice hardly anything, other than you may notice the stars might dim a little bit after the process is completed and it's done. The next thing I'm going to do is something called background extraction. Not clear what the benefit of doing this is or what it's even doing, but I'm doing it because, I don't know, it's recommended. First thing you do is press the generate button, and that'll generate all these little red squares across the screen. Notice that there are some spaces where there are no red squares, and that's because the software is not going to put a red square somewhere where it's detecting some sort of a light signal from a star. One of the things you want to do is just kind of give this a cursory look and make sure that there are no red squares that contain a star within them. If you do see one, you would remove it from the screen, but in this case it looks like everything came out as it should. So once I've verified that none of these red squares have a light source in them, I will click on compute background, and that process will complete, and I will apply it. And again, you probably don't notice any real difference in what you're looking at, but it's a step in the process and it's been completed. Alright, the next thing that we will do is now we will change from linear format to the auto stretch. I'm going to activate the auto stretch, and notice the big difference here. Now that we have auto stretched the picture, we can actually see some structure of the nebula C20. I think it's also called the North American Nebula, if I'm not mistaken. Correct me on that if I'm wrong. We can see some structure, some cloud-like structure here. I'm kind of going over it with the cursor. And of course a whole bunch of stars that have really jumped out. So this is our initial look at the object C20. It's kind of hard to make out, but you can vaguely make it out. The result of probably only using 67 pictures to create the image. With 200, we might have a better shot of this object here. It might look a little bit better with more detail filled in. Anyway, so with our 67 stack, we'll just go with what we got and see what we can do to improve on this image. So we can see some parts of the C20 nebula. There's some other parts that are way over here too, but I'm going to focus on this part kind of right here in this area. One of the first things I'm really going to do with this image is I'm going to crop it out, and I'm going to crop it down just to the area of interest. And another purpose of doing cropping on all these images, it's recommended you do it on all your astrophotography images. Another purpose of the cropping is on these images there are going to be artifacts laying out on the edge of the image. And before you do any heavy-duty processing on this image, you do want to not have those artifacts be involved in any of the calculations. So we need to crop those out and make sure those don't appear on the image. I'm just going to further crop the image to just focus in on the area that I'm interested in, which is that area right there. Right click in the square I drew and choose crop. And this is the resulting image that we are now going to work with going forward. Again, we can see a little bit of a better view of our nebula here. There are a lot of stars that are in the way, and we're going to deal with those. Okay, what else can we do with this image? Looking at it, you may notice it appears there might be a bit of a green tint to this image, and that's something called green noise. We have a tool for removing that. So let's remove the green noise. And I'm just going to take the default because I've not really played around with this tool any, other than the default setting seems to work real good, so we'll stick with it. And the green tint to this image is now gone, so that's good. Now, there's a ton of stuff we can do with this image to help improve it. One of the things we can do is called color calibration. So I'm going to do that now by selecting the color calibration tool. The way this tool works is you define two areas on the image. One area you define that serves as a selection of the background of the image, or an area where there appear to be no stars. Then the other area I will select will be what they call a white balance image, and that'll be an area that has stars in it that we can use to help balance out the white. Anyway, so the first thing I'm going to do is select a background area suitable, and this looks pretty good right here. Just draw that in and tell the software that I want to use the current selection, and then click the background neutralization. Box disappears. Next, I will draw an area for white balance. I'm gonna go with this area right about here, including one bright star and some other little stars. I'm not sure if that's the right and proper way to do it, but that's the way I'm doing it. Okay, we will select use current selection on this one. Once we have done that, we will click apply. And we are done with that tool. Didn't really notice much of a difference in the image. Sometimes color calibration will reflect a difference in the image. Sometimes it doesn't show much of a difference. But either way, it's another recommended tool to be running on this image. And we're done with that. Next, I'm going to skip over color saturation because I'm going to deal that with what I would like to call post-processing. We've removed the green noise. Let's look at the bag of filters that this software includes, and there's quite a few of them. Each one of these does something specific and different, and I'm still learning what most of them even are. I do have a few of them here that I like to use right away because they seem to be fairly effective on most images I've worked on. I like the banding reduction tool. I'm going to use that. And just over trial and error, I've learned that I kind of like to click this protect from highlights box, crank this up about halfway, crank this setting up about 2/3 or 3/4, and then click apply. Didn't really see much of a difference. Sometimes that'll clean the image up a bit. Oh, there it is. It cleaned up a little bit. Had to wait for it to complete processing. And once I've done that, I will now click the vertical banding. It just did horizontal. By ticking this, I will now have it do vertical also. Click apply again. Wait for that process to complete. And there we go. It's done. So the banding filter has been applied. I want to also check out the I'm not sure about that one. Let me go to the noise reduction filter. This one is sometimes useful on these images, and sometimes it isn't. When it isn't, it's very apparent to you visually that it's not a good tool to use. But let's find out if it'll be a good tool to use on this image or not. Again, I'm just going to take the defaults on this one. Choose apply. Wait for the process to complete, which we can track on the progress bar down here. Oh yes, that provided an improvement to the image. That's good. Like I said, when this tool doesn't work well, it'll leave artifacts all over the screen. It's obvious that it didn't work well, and you can undo it if it didn't work. In this case, it worked pretty good, so we're going to keep it. Okay, at this point, I think I'm done with the filters that I'm familiar with that I would like to use. I've done the background extraction. Yeah, at this point, I'm going to do something called star processing. And what this process is going to do, I'm going to click on star removal. And what's going to happen is the software will then now take this image and it'll separate or remove the stars from the image and just leave anything on the image that is not a star. So that you end up with two separate images. One that's called the star mask that has all the stars on it, and another image that's called the starless mask. It has no stars on it. The purpose in doing this is it does give you the opportunity to work on editing the starless image, the image without stars in it. In other words, that would be an image that just has the nebula and noise and stuff in it. You can maybe work on bringing out some more detail that way without the stars being involved in the process. After you're done with that, you can then put the two images back together into a single image. Anyway, that's the process I'm about to do right now, and it starts by selecting StarNet Star Removal. Again, I'll be selecting the defaults on this with these default things selected. Sometimes I will recompose the stars on completion, because sometimes there's really nothing you can do to improve the non-starless image. But we'll take a look at the non-starless image this time, though, and see if we can improve it a little bit. So let me execute this. Sounds like I just got a text. And it's not important. All right, still waiting for this process. In fact, we can watch the progress bar down here. This will take a minute or two. The larger the image is, the longer it will take. Okay, got a report after that was done telling us that the execution time was 1 minute and 52 seconds. Here we see it'll display for us the image without the stars in it, or the starless image, if you will. And yeah, we can see a lot of this nebula here. There's also a lot of other noise too, and you know, with a crummy telescope and not enough stacked images, that's going to happen. Like I said, more often than not, there's really not much you can do to improve this particular image. But one of the things I do like to check to see if it is effective, because sometimes it is the what's called the A-sign transformation, particularly the black point. I do like to check and see if there's any leeway between where the black point craps out. So we've got to slide this slowly over. You don't have to go over very far before that image will disappear. There we go. Bring it back a little bit. Let's see if we can take this one. Whoop, there we go. Yeah, this is a case where the difference between the image and the heavily filtered image is not, is a ton. There's a big difference between the two. Sometimes you can get a point where it's a very more not as an abrupt a difference between those 2 points, and you can maybe find a spot somewhere in there where you can eliminate a lot of that noise and bring in some more black background. But in this case, that's not going to work. That ain't going to happen. So what we'll do is take it right back to this particular point right here and just keep that. So that was literally very little improvement. Actually, I would say no improvement to that at all. There's one more thing we'll be able to do to this to help bring out some more detail, but that's done when we recombine the two images. And I'm about to do that right now. So, at this point, I will now go, don't want a script. I want to go to the image processing, go to the star processing, and we want to recomposition stars. Oh, this is warning me that I forgot to save this image. So let me cancel this and make sure I got this image saved, and I get the confirming message here that the image was saved. And now I will do the star processing, star recomposition. And in this box here, I want to load the starless image. Notice that Cyril created two new files and put them in the working directory. It created a starless result and it created a star mask result. I want the starless result here to load in this window. And while I've got it loaded here, and before I load the star mask, I'm going to come over here and highlight an area of this nebula that seems to contain a fair, I don't know how to say this, a fair amount of difference in the detail, or a lot of different detail information. I want to highlight an area like that somewhere on the nebula. Then come in here and click on the eyedropper tool. That tells the software what area I want to use to anchor the stretch factor, I think, or something like that. I don't know. Probably not explaining it right. But anyway, select an area like that on the nebula and tell the software where it is, and then go to the stretch factor and start stretching this puppy and see if you can bring in any more detail on that thing. Might have to go quite a ways on the stretch to see it, but we keep going. Notice how it's brightening up. There we go. I like that. So that's getting better. That's bringing out a lot more of the detail in that nebula. Notice it also does increase the noise everywhere else in the image too. So there's, like most things in this type of image processing, there's trade-offs in everything that you do. But in this case, I like the improvement it has made to the nebula itself versus how much it increased the noise. So I'm going to go ahead and apply this right at this point. And now I'll come over here and load up the star image, which is the star mask. And now that we got that appeared, let me slide that a little over. And that's not looking too bad, actually. In fact, it looks like the star mask could use a little bit of a boost itself also. So in the case of the star mask, I'm going to go find a spot that has a lot of blank in it and highlight it. And then click the eyedropper tool. And now let's stretch factor the star mask and see what we can do with this image. There we go. Bringing in more stars. Yes. It's a lot of stars, but it does make the image look a little better. At this point, it's kind of a personal preference thing. How many stars do you want to see in the image? This probably be a good point to talk about how, astrophotography at some level becomes more of an art than a science. I mean, operating the telescope, gathering the images, that's pretty much pure science. But once you've processed the image to a certain point, you begin to leave the realm of science and really enter the realm of art. And at this point, it really becomes a personal preference issue on what you like to see in an image and how you're going to manipulate things to make the image show that. And I guess, in my opinion, that would be the art part of creating your astrophotographic images. Anyway, I just kind of wanted to mention that and how I felt about it. It does seem like there's more art than science to this sometimes. Okay, anyway, so I boosted the star mask a little bit and brought in a few more stars to make this image look a little better. The image is still real noisy, and really not a lot I can do about that other than to try to take a lot more pictures, make a much larger stack, and hopefully reduce the noise in the image that way. But in this case, I've only got 67 to work with, so we'll just accept that as it is. I'm going to click apply on that and then close this out. So at this point, let me make sure there's nothing else I want to do with this based on all these tools that are here. And no, that's pretty much all I'm familiar with. So at this point, I am done with the image processing in Cyril. I am going to process the image a little bit further with traditional image processing software, or graphic software, if you will. But right now, what I want to do is click on Save as a Unique File. And Cyril will now save this image as a PNG file to the working directory. There's my working directory. There it is. And there it is. There's the PNG file of this image that Cyril has created. At this point, I am done with Cyril. Close it. Exit. And what I want to do is I want to do a couple more things with this image to make it look a little better. I'm going to open it with, come on computer, Corel Paint Shop Pro 2023, the cheap-ass graphic software that I use. I don't use Adobe because I don't want to pay a monthly subscription or pay the enormous money for an Adobe package. So I use cheap off-the-shelf software you can buy that's, yeah, it's cheap, but you know what? It gets the job done. I think with me running OBS Studio to record this and trying to demonstrate software at the same time, it is really slowing down my PC. In fact, I'll be surprised if there's not some video problems possibly happening. God, this is taking a long time. Holy hell, all right, finally. All right, so the very first thing I'm going to do is I'm going to go straight to brightness and contrast to the levels tool. This is usually pretty effective at cleaning up some of the noise. There, boom, without even doing anything. It already improved the image and made it look a little better. Let me operate this slider right here and see if I want to take this any further or lighten it up a little bit. No, I think I want to keep it right about there. I like that. Choose OK. And now I'm going to go and use the haze removal tool. This is also effective at helping to clean up some of the noise after the levels tool has been used. There's a bit of a difference before and after. I like it. And I'll take the results of that. Alright, the final thing I'm going to do with this here in Paint Shop Pro is enhance the colors a little bit. Let me go to Vibrancy. And I got it set at 36. It seems reasonable. Choose OK. And I'm going to call this my final image. Yes, it looks kind of noisy, but you can see some structure of the North American Nebula, I believe it's called, or C20. The other thing that I will say about this picture is, viewed in a smaller format, it'll actually look better. But let's save this. And that should have saved right back to the working directory. I am done with Corel. And in fact, I am done with the... Am I done with the desktop? No, let's have a look at the resulting PNG file. And that's really the end result of all the processing I've done on the 67 photos I got of the of the North American Nebula, or C20. Not a great picture, but hey, for a cheap telescope and complete lack of knowledge and skills, not bad. Not bad. Anywho, there's a demonstration of how you can take a cheap telescope and try to put it to use to take pictures of deep sky objects, and then further improve on those pictures using astrophotography software. That's it for now. Ta-la.